tutorial about FEMM software, Finite Element Method Magnetics. Introduction. FEMM, Finite Element Method Magnetics, is a software package used for solving low-frequency electromagnetic problems. It is commonly used for design and analyzing magnetic and electric fields in various engineering applications, such as motors, transformers, sensors, and inductors. FEMM is free, easy to use, and provides powerful simulation capabilities for 2D planar and axisymmetric problems. This tutorial will guide you through the basics of using FEMM to create and analyze a simple magnetic circuit. Step 1. Download and install FEMM. Visit the official website and download the latest version of the software. Install. Run the installer and follow the on-screen instructions to install FEMM on your computer. Step 2. Creating a new problem. Open FEMM. Start the FEMM application. You will see the main interface with several toolbars and a blank workspace. Create a new problem. Go to File, New. A dialog box will appear where you can set up the basic parameters for your simulation. Choose the type of problem you want to solve. For magnetic field problem, select magnetic problem. Select the planar or axisymmetric type based on your design. Choose the frequency of the problem. For DC or static magnetic problems, set the frequency to 0. Set the units, millimeters, centimeters, etc. for your design. Click OK to create the new problem. Step 3. Drawing the geometry. Draw components. Use the toolbar on the left side to draw the geometry of your problem. Use the Line tool to draw straight lines and the Arc tool for curved sections. To create simple shapes like rectangles or circles, use the Rectangle and Circle tools. For example, to create a magnetic core, draw a rectangle representing the core material and a smaller rectangle inside it, representing an air gap. Define boundary conditions. Go to Properties, define boundaries. Define the outer boundary of your problem by setting it to the directly fixed potential or Neumann, no normal component of flux. Step 4. Assigning material properties. Assigning materials. Go to Properties, Materials. You can choose from predefined materials or create a new one by entering its properties. Permeability, conductivity, etc. Select the block tool and click inside the regions of your geometry to assign materials. For example, assign steel to the core and air to the surrounding space. Assigning coils, if needed. For magnetic problems involving current-carrying coils, you can define a coil region using the Coil tool and assign a current value. Step 5. Meshing the geometry. Mesh generation. Before solving, you need to create a mesh that divides the geometry into small elements. Click on Mesh, Generate Mesh. FEMM will automatically create a mesh based on your geometry. You can refine the mesh by adjusting the element size under Mesh, Set Default Element Size. Step 6. Solving the problem. Run the solver. After setup the geometry, materials, and mesh, run the solver by clicking Solve Analyze. FEMM will compute the solution and save the results. Step 7. Viewing results. Post-processing. After solving, you can view the results by clicking View Results. use the post-processing tools to visualize the magnetic field, flux lines, potential, and other relevant quantities. You can also plot graphs, calculate force, and evaluate integrals over regions of interest. Step 8. Exporting data. Save and export. You can save your FEMM file for future use by going to File, Save As, export results, plots, or data by using the export options under the post-processing menu. Conclusion. This tutorial covers the basic steps to get started with FEMM. As you become more familiar with the software, you can explore more advanced features like parameter sweeps, nonlinear materials, and transient simulations. Fans documentations and user forums are also great sources for learning more about specific filters and applications.